Okay, so let's talk about Chapter 3, Organization of Electricity Markets. So in Chapter 2, we talked about the basics of economics, especially from microeconomics perspective. And the examples were wheat, oil, cocoa, rice, barley. What is barley? Do you know barley? No. Barley, barley. Okay. Anyway, so these are the common goods traded in the market, in forward market or future market or option market. But no, we want to trade electricity, and there are some differences between electricity and other commodities. The first one is electricity is inextricably, which means it cannot be separated, okay? Inextricably linked with physical delivery system. I emphasize this a lot, in this course. So physical delivery system operates much faster than any markets. Actually, yeah, it operates at the speed of light, right? And the generation and load must be balanced all time. So, you know that if load is higher than the generation, for example, in a hot summer day, the blackout can happen. But the opposite is also true, which means if there is more generation than load, we have the same risk of blackout. Okay? So generation and load must be balanced at all time, at all seconds. That's why this is power system economics, not energy system economics. Energy is power times time. Power is instantaneous one, right? And generation and load must be balanced at all time. Okay? And failure to balance leads to collapse of system. A part of the system or the entire system. And this is really problematic in many senses. The first one, from industrial perspective, for the semiconductor company, they need to reboot their manufacturing facilities, but also to reboot the entire power system takes a lot of time. It is not just like turn on the generator switch. It takes several times or 24 hours or more than that, because we have a power system, we have many generators, and they are connected by transmission lines, and there is a sequence to turn on each generator one by one. Okay? And one generator needs to be added later. There is a sequence. So this is very, very hard job. Yeah, economic consequences of collapse are enormous, as you may imagine. So balance must be maintained at almost any cost. So that's why this physical balance cannot be left to a market. So somebody needs to intervene in the market. Balancing generation load, this can happen using market mechanism, but we need to do that at all time, at any instance. That's why we have another party that deals with that. Who deals with that? In Chapter 1, we discussed that. Actually, in Chapter 1, there are many keywords, so maybe you were confused or puzzled. But who is responsible for balancing the power system? ISO, Independent System Operator. Okay? There are several system operators, SO, ISO, TSO, DSO, blah, blah, blah. But ISO and TSO are almost same. And independent means that ISO is a non-profit organization. They are independent from generator. They are independent from retailer. Okay, and their job is to balance the power system at all time. And ISO in Korea is KPX. So maybe later you have a chance to visit KPX, and they solve the power flow every 50 minutes. And I will show you some funny video later, not today. Okay. Yeah, so physical balance cannot be left to market, and ISO undertakes that duty. And to effectively manage the generation, the electricity produced by different generators is pooled. So this pooling is used a lot in power system economics, and I will go to this point maybe chapter 3, chapter 4, or later. Okay. So this means that we have a electricity pool. That means we have a number of generators, and they just inject their power into this pool. And for simplicity, we assume that all the generators and all the loads are connected in a single bus, or a lossless network with infinite capacity. Same thing. Okay. What is bus? Bus is not the bus you get on every day. The bus I mean here is just a copper plate. Okay. With zero resistance. So generators just injects their power into this pool, and loads just draw the power from the pool. Okay, so we have a common pool. But the thing is that generator cannot direct its production to some consumers because we have just a pool, and the electricity cannot be distinguished from A generator or B generator. All the electricities are same. Okay? And also, consumers cannot choose which generator produces the energy it consumes, because energy is pooled, power is pooled. This is traditional concept. Okay? But these days, the HING studies P2P transaction in distribution network, distribution market, and in that case, the producer and consumer wants to be connected to each other. They want to designate the producer or consumer, because that is P2P trading or bilateral trading. So this assumption may not hold in an emerging market. So this is a traditional view. Yeah. So traditionally, electrical energy produced by all generators is indistinguishable. They are same. And this pooling is economically desirable. And from optimization perspective, this pooling concept makes solving problem very easy. Okay. Yeah, and a breakdown of the system affects everybody, so this pooling concept is okay. So we talked about the generator side, and next let's talk about the demand side. The demand for electricity exhibits predictable daily, weekly, and seasonal variations. So some of you did the load forecasting before. And the forecasting of electricity load is similar to other commodities like coffee or cocoa. But there are some difference. The electricity cannot be stored in large quantity. This is traditional concept. what does that mean? These days, we try to store energy in large quantity using large-scale energy storage system, ESS. But from traditional perspective, electricity must be consumed when it is produced at the speed of light. When it's generated, it is consumed. So actually, yeah, even though we are talking about electrical energy, there are different types of energy like gas. Gas is gaining its popularity a lot. Its price is very high these days. This is why currently CAPCO is suffering from deficit a lot. What I want to say. In this gas pipeline network, we have a pipeline, we have a gas, like methane, or what else? Liquid what? Natural gas, yeah. So because we have a pipeline, this pipeline can store gas. So gas can be stored anyway in the network. Electricity is not like that. And the next thing is production facilities must be able to meet peak demand. This is another important thing. And this kind of situation happens commonly in network. When you use high-speed internet or when you speed mobile network, the network capacity should be determined to cover the peak load or peak demand. Otherwise, you will experience the service shortage time. Similarly, in power systems, the production facilities must be able to meet peak demand. That means sometimes some generators just need to in a standby mode. Even though they do not produce any power, they just stand by to meet unpredictable high demand. Okay, and this is another characteristics of electrical load. Their price elasticity is very low. Even though the price changes, people do not want to reduce or increase their consumption. So demand curve is almost vertical, traditional concept. And these days we are talking about demand response, as I told you. And in Korea, the total generation means the total demand in a hot summer day is almost 90 gigawatt. Right? You remember that. And the demand response is abbreviated as DR. In Korea, there are many DR providers, including Gridwiz, Byeoksan Power, blah blah blah. Many demand response providers, and so they need to collect large building or factories or even residential customers, so that when this DR event happens, they request to the customers, hey, please reduce your load, and then I will give you this much of incentive. Okay, and check it on your own, but the demand response capacity, which means when the DR event happens, how much can we reduce? That is order of gigawatt currently, okay, a few gigawatt. That means that is comparable to the generation of nuclear power plant. Okay. So, yeah, this is traditional concept. Price, demand curve is almost vertical, but these days, demand can respond. And the next question is how much we need to give the incentive to the customers. And in Korea, no, there is a concept of 국민 DR. So traditionally, the demand response participants are large facilities, building, factory, who consumes megawatt, tens of megawatt, etc. But this 국민 DR means that residential customers can participate in this DR program. Of course, there is an aggregator. Aggregator. You should be familiar with this kind of terminology. Aggregator, or called 중개사업자. So this aggregator collects the residential customers, and they participate in the DR market instead of the residential customers. Okay. So yesterday I heard that Gyeongnam DR provider gives incentive pretty much like when you reduce, okay, suppose that DR event happens and this DR provider asks you to reduce your power consumption 10% compared to what you consumed 1 week before. Okay? So you need to reduce your power consumption for 1 hour by 10% compared to the baseline. If you succeed that, you can get 2,500 won. You can buy a coffee using that money. That's a lot. Yeah, that's a lot. But typically that's not the case. Typically less than 100 won. Okay? And so to make DR works well, it is very important to determine what is the proper level of incentive based on market mechanism. But currently, now we are talking about market a lot here, but the situation in Korea is not quite based on market mechanism because we have only a single monopoly company and the government regulates it strictly. Okay? And the electricity price does not reflect the generation cost. These days, the price of natural gas blows up. Anyway, do you have a question, 민수? Yes.
파워 컨섬션에 대해서 인센티브를 준다고 하셨는데 제가 알기로 제주도 같은 경우는 발전량이 많아서 문제가.
Yeah. So next question is next problem is that. Yeah, thank you for bringing up this issue. For some reason, we need to ask to, hey, please reduce your power consumption. But for another reason, like Jeju Island, Jeju Island, the renewable power generation is like 20% or more than that. So sometimes it generates a lot. And the kind of wind turbine or photovoltaic, solar panels are connected to the distribution network, but some of the distribution networks are congested because at some time on a sunny day, the solar panels generate a lot of power, so the network cannot handle it. So in that case, we have two options. The first one is, we have DR, but it asks the customers to reduce their power consumption, but the opposite of that is called plus DR. Plus DR means that, hey, please increase your power consumption. Okay, there are a lot of power generation from solar panel. Okay, so to balance generation and load, please, then I can give you money. Okay, so that is called plus DR. And another option is to ask the renewable producers to curtail their generation. That means the loss of generators. Okay, they get money based on the total amount of generated energy. But when the distribution network is congested, the network operator, actually, independent system operator, or CAPCO, is not quite sure. Anyway, so somebody need to ask the renewable producers that please curtail your power generation. Okay, so that topic is very recent topic, and in the Parliament, 여의도, they recently agreed on a new law, which is about distributed energy resources. And so please check it. You can find some news articles about that. And the controversial and sensitive issue is about how can we compensate the renewable producers when they curtail their power generation. How much do we need to? Okay, first, can we ask them to curtail their power generation? Second, if they do that, how can we compensate their loss? Okay, and putting some single line of statement in the law is very difficult, hard, and it affects a lot of participants in the market, and we have a lot of stakeholders, so which is not an easy job at all. So we are talking about the technical side, but in this energy market, we have policy as well.
그러면 저 방법이 두 가지 있다고 했는데 커텔이랑 플러스 TR이랑
Yep.
HVAC인가 그 발전량을 남은 발전량을 그 내부로 그 보내는 방법도.
Okay, so Kunju is talking about HVDC, high voltage DC line. So we have currently two HVDC line that connects Jeju Island and the mainland of Korea. So when there are a lot of renewable generation in Jeju Island, one way to solve that is install more HVDC. But it requires a lot of investment. We need to install the underwater cable.
지금 실제로 저 연결되어 있나요?
Yeah. There are two HVDC lines. So I visited, this location where the HVDC is constructed, and so the key point of HVDC is to conversion from AC to DC and DC to AC using power electronics. So you may heard thristor. I'm not quite good at spelling, so please check it. So this is based on power electronics, and so it's about the conversion AC and DC at a very high voltage. Okay. Anyway, so a lot of new things are happening these days in this field. Yeah.
그 재생에너지 사업자들한테 이제 발전량을 줄이라고 한다고 하셨잖아요.
Yes.
근데 이제 다 같이 발전을 했는데 꼭 그쪽에서 줄여야 되는 이유가
Yeah, another good question. So, actually, we are not talking about at all about the topology of the distribution network, but typically, distribution network is a radial structure or tree topology. So, this is we have a substation here. Substation means 변전소. And then we have several buses, and they are connected like this. So there are load here or load there. So this is the symbol of load. And the symbol of generator is this. Okay, so traditionally, generators are here. And then power flows from upside to the downside, for example. But in the case of renewable generation, PV or wind, they are directly connected to this distribution network like that, or like this. Okay, so when it generates a lot, this line can congest it, or that line can congest it. And when some of the lines are congested, then they cannot have more power flow. So they need to ask, hey, please stop generating more power. I'm at my full capacity. Okay, so that's why they ask curtailment. And then next question is, who has the right to ask curtailment? Is it IESO or CAPCO? Who? And based on which, based on what? Do they have that kind of right or not? Because no, this is about economics. These renewable producers should make money. That's why they need to install solar panel or wind turbine. Okay? So that means the regulator or operator infringes on their economic profit. And then these renewable producers can sue the government, for example, or IESO, or CAPCO, etc. So policy, law, money, all of these things are interconnected, plus techniques. So I want to talk about only techniques, okay? Technology only, the politics, law, blah, blah, no, they are very complicated, okay? And there are a lot of other experts in that area. Any other questions? Let me stop here because we need to talk about a new topic, trading periods, and then